Welcome to the Crazy Hat Chemist. So here we are doing another video on periodicity. Let's get moving. Bam! So why atomic radii increases going down a group? So as the principal quantum number n increases, the outer energy level is used. That is, you're going from n equals 1 to n equals 2 to n equals 3 to n equals 4, etc. The electrons in the outer energy level, those are the valence electrons, are held less tightly by the positive proton charge of the nucleus. This is because of the shielding of the positive nuclear charge by the core electrons, thus increasing the distance of the outer electrons and therefore increasing the size of the atom as one moves down a group. So I want you to look at that diagram right there on the bottom there, and in the middle there is the nucleus, which contains the neutrons and the protons. Remember that AXZ standard nuclear notation? The Z represents the number of protons, which is the atomic number, i.e. the number of protons in the nucleus, which are positively charged. So there's a dense central nuclear core that has neutrons and protons, which are positively charged. Okay, now we're going to take a look at those electrons, and the electrons are negatively charged in these orbitals. You see two orbitals, n of 1, n of 2 in this case. Okay, these are attractive forces. That is, there are attractive forces between the electrons and the nucleus that are on the protons. Okay, the protons in the nucleus, right? Okay, now these are representing repulsive forces. That is the same charge, that is the negative charge of an electron and a negative charge of an electron are repulsing each other. So just like the Vesper theory, where we're trying to remove or move the electrons as far away as possible, the negative charge, we're trying to do the same thing here with electrons. And that's why the electrons are moving farther away from each other when they are close to each other. Okay, so hopefully this makes a little sense. So why the atomic radii increases going down a group? So here's an analogy here for you. In the nucleus is the king and the queen, and they're of course positive and neutral, if you will, the positive protons and the neutral electrons. Okay, everybody wants to get to that positive charge held by the king and the queen in the nucleus. Now, the first energy level, n equals 1, are where the nobles are, and they, which have electrons, they are attracted to the king and the queen, and they have direct contact between the nobles and the king and the queen. Now, the next energy level, n equals 2, if you will, are the knights. And the knights have to go through the nobles to get to the king and the queen. Every now and then the knights can get into the king and the queen, but not very frequently. So you should see that as you get n equals a larger and larger numbers, you get farther away from the nucleus. Then we have the peasants and the serfs. The peasants and the serfs are outside the knights. So you should see that the king and the queen are protected and by the nobles, which are protected by the knights, and then the peasants and the serfs are outside. Okay, the peasants and the serfs are being shielded by the knights, the nobles, to get to the king and the queen. I haven't heard of very many peasants or serfs who have been able to reach the king or the queen. They only can talk to the knights or the nobles, and even at that, it's very difficult. So therefore, they get a little bit larger because of that shielding effect. That is, the knights and the nobles are shielding the king and the queen from that negative charge held by the peasants and the serfs. Okay, so hopefully that's an analogy for you as you go down a group. And those outermost valence electrons are not held as tightly because they're in larger principal quantum energy levels. And there's electron repulsion that is occurring by the inner shell of electrons. Okay, that was a great video by the Crazy Hat Chemist. And I got one cool furry hat, baby. Okay, if you like that video, give me a thumbs up, subscribe to my YouTube channel. Please pass on my YouTube channel to other people who need to and want to learn about awesome chemistry. Okay, got lots of information for you. Have a great day and see you next time. Bye now.